We will now try and see what a simple basic air brake system looks like. In a train, we have a locomotive. The locomotive is connected to a number of trailing cars. These cars can be either wagons or coaches. The locomotives and the cars amongst themselves are connected through mechanical linkages called couplings. However, couplings are not the only connections among the cars and the locomotive. There is a brake pipe which runs along the underfloor of each car. These brake pipes are connected between the car and from the end car to the locomotive through rubber hoses. This is a rubber hose, and since this is connected in the brake pipe, this is called a BP hose. There is a compressor in the locomotive. This compressor takes in atmospheric air, compresses it, and fills a main reservoir. The main reservoir supplies this compressed air to the brake pipe. However, this is done through brake valves, and one of these brake valves is the A9 brake valve. This is also known as the automatic brake valve. When the driver wants to operate the brakes of the train, which means when the driver wants to apply or release the brakes, he controls the A9. Under the floor of the car, we have the brake pipe. This brake pipe is connected to a triple valve, also called the differential valve. Remember, the brake pipe is already at a raised pressure. The DV or the differential valve has a few other connections. There is an auxiliary reservoir which is a cylinder of air connected to the DV. The DV is also connected to a piston cylinder arrangement which is called the brake cylinder. The piston in the brake cylinder is backed with a spring for return force. The piston on the other end is connected to the brake blocks. There is another port on the DV which exhausts to the atmosphere. As soon as the driver wants to apply the brakes, he reduces the pressure in the BP by applying the A9. This reduces the pressure in the BP. When the A9 is not applied, the AR and the BP are at the same pressure, basically because the AR in such a case is always connected to the BP. As soon as the A9 is applied, the pressure in BP reduces. The DV keeps on comparing the pressures in the AR and the BP. As soon as the BP pressure falls, a slider mechanism in the DV operates, basically pushed by the AR pressure which is now in excess from the BP pressure. This causes the AR to get connected to the brake cylinder or the BC. This causes the piston in the BC to be pushed outwards, causing the brake blocks connected to the piston through certain linkages to clasp the wheels. This causes increased frictional force between the brake blocks and the wheel tread. This reduces the speed of the train. The brakes are now in the applied condition. Till the BP is in reduced condition, the AR will keep on supplying air to the BC. Now when the driver wants to release the brakes, in such a case the A9 is now brought to the release position. In this case the BP pressure raises. A raised BP pressure will cause the slider to move back, and the BP and the AR are then connected. The AR pressure that would have reduced by supplying air to the BC now gets charged from the air coming from the BP. At the same time, this movement of the slider inside the DV causes the BC air to now vent out through the exhaust port of the DV. The spring mechanism inside the piston causes the piston to be pulled back into the BC, releasing the clasp on the wheels. This releases the brakes.